Good morning, students. Today in chemistry class, we are going to discuss about a topic from first chapter, that is matter in our surroundings. In previous classes, we discussed about characteristics and physical properties. Today, we are going to learn about changing states of matter. We know matter contains smallest particles. These particles are very far away from each other, and these particles can change their state. Matter can change their state from solid to liquid, liquid to gas. How it will change? That is what we are going to learn in this present class. What we are going to learn this topic in this subtopic is effect of temperature and pressure on changing of states of matter. About melting point, fusion means, latent heat of fusion means, boiling point means, vaporization means, latent heat of vaporization means. So about this total topic we are going to learn in today's class. Before going into this topic, we need to know some basic points, that is atmospheric pressure and heat and temperature. These three important points you have to know. General atmospheric pressure means it's a pressure exerted by the which we can see within atmosphere of earth. We can say that atmospheric pressure is the pressure within atmosphere of earth. Very simple. It is denoted by symbol ATM, atmosphere. Small letters ATM, atmosphere. This atom is set to atmosphere. Generally, we say that on earth atmospheric pressure is 1 atmosphere, which is equals to 760 mm of Hg, which we calculate by using barometer. So atmospheric pressure is the pressure within atmosphere of earth, which is taken as generally 1 atmosphere. In chemistry, generally we use 1 atmospheric pressure. Next, heat. We must know difference between heat and temperature. Both seems to be almost same, but actually the difference is heat. It is a form of energy. Remember, heat is a form of internal energy that is possessed by interior part of the body of the object, which is because of random motion of particles and attractive forces between the particles of the substance. I am repeating, heat is a form of internal energy that is possessed by an object because of its particles motion as well as its attractive forces. It is a form of energy, so its unit is joule. Temperature. What about temperature? It's very simple. It is a quantity that determines that or measures that heat. Remember, temperature is a measurement of heat. In simple words, we can say like that. It is a measurement of heat. It is a quantity that determines which direction the heat energy will flow. Generally, heat energy will flow from high to low, from higher value to lower value. That value is said to be temperature, which is calculated with SI unit means Kelvin, CGS means Celsius. I am repeating the difference between heat and temperature. Heat means it is a form of energy possessed by object. Temperature is a quantity that determines that amount of heat in the object. So with these basic points, we can go into the chapter. The main topic is changing the states of matter. Generally, we have 3 states of matter. Physical states are 3 states: solid state, liquid state, and gaseous state. If we take water, which is said to be which exists as a solid, which is said to be ice, which can exist in a liquid state, which is said to be water, which can be converted to water vapor, which is in gaseous state. The water can be like a solid, can be liquid, can be gas. 3 different forms are there. Okay, So water can exist as a solid, liquid or gas, three different states. How these three different states are possible for one matter only? We can change the physical state of a matter in two ways. One is by changing the temperature. Let's see. First topic, by changing temperature. By changing temperature, how we can convert physical state of a matter into different forms. Just by increasing temperature means, remember, very simple, by supplying heat, that's it. Heat is a form of energy that is given to the system. Temperature is a measurement of that heat. So temperature is not directly given to the systems. So by increasing temperature, that means by supplying heat to a solid like ice, that is converted to liquid. How it is converted to means, remember, when you remove the ice cubes from a refrigerator, we are not going to give the heat to the ice cubes. Just keep the ice cubes in a plate or glass. Within a minute, it converts to liquid state. It absorbs heat from the surroundings. We are not supplying heat, but it absorbs heat from the surroundings, so default. That is why it is converting from solid to liquid. And that liquid, if we are supplying extra heat from outside, this liquid converts to gaseous state. So by increasing temperature, solid can be converted to liquid and the liquid can be converted to gas. If we decrease temperature, like cooling, gas can be converted to liquid. Liquid also can be converted to solid. Take same water vapor, apply some decrease temperature, slowly it converts to liquid. Still, if we decrease temperature, it slowly converts to solid. So how it is converted, why it is converted, we can discuss about this in a following topic. Let's see first, solid to liquid. In this solid to liquid subtopic, we are going to learn about melting point, fusion, latent heat of fusion. These three main points. If you are perfectly thorough with these 3 points of melting point, fusion and latent heat of fusion, in next subtopic related to this, again 3 subtopics will be there. You can understand that 3 subtopics very easily. So let's see. I am taking an example of ice. So which is removed from a refrigerator. It is absorbing heat from surroundings. Or I taken a beaker, or we can do the activity like this. We can take a beaker, keep the ice inside that and keep it on a burning splinter. So heat is given to the ice now. This heat which is given to the ice, this ice changes to water. So ice which is solid state changes to liquid state. But how this state is changing, how it is happening? This is because when a solid substance is heated, like ice is heated, the heat energy, generally in solid state, particles are very close to each other. They are very strong attractive forces. They have very strong force of attractions. When you supply the heat, it makes that particles which are strongly attracted, makes that particles to vibrate with more speed, and particles move from their original position and they move with high velocity such that they overcome the force of attraction that is holding them in a fixed position. And this solid melts to the liquid. I am repeating the point. Carefully try to understand this. We are discussing a topic called solid to liquid. How solid converts to liquid. That is what we are going to discuss. When a solid substance like ice is taken, when you are applying heat to that, it slowly converts from solid to liquid. Very simple. Physical appearance is very simple. Solid to liquid. How it is happening means, in a solid, particles of a solid have strong force of attractions. When you are applying heat, the particles absorbs heat and overcomes the attraction between the particles and they move with high velocity with a sufficient kinetic energy such that they overcome the attractions. Because of the increasing kinetic energy, slowly solid state converts to liquid state. So it is called solid melts to form liquid. This is the process happening inside. Now, melting happened. Melting means the process in which solid substance changes to liquid. Very simple. Melting means the process in which solid converts to liquid on heating. It is said to be melting. Melting point is one type is there. Let's say afterwards. Fusion means the process of changing that state from solid to liquid by melting is said to be fusion. Melting and fusion almost same. Melting means it is a process in which solid substance changes to liquid on heating is said to be melting. Fusion means the process of changing state from solid to liquid. The process of changing of state from solid to liquid is said to be fusion. Whereas melting point means it is a temperature at which a solid substance melts and changes to liquid at atmospheric pressure. So fusion and melting is almost same. Melting point is quite different. The melting point is a temperature at which solid substance changes to liquid at atmospheric pressure. So learn this definition properly. Melting point is a temperature at which solid converts to liquid state at atmospheric pressure. Because all these things, see, I take an ice in a beaker, I am heating this. This ice is exposed to the surroundings which has 1 atmospheric pressure. So outside atmosphere will affect this. So I have to mention this atmospheric pressure also in the definition. So melting point means the temperature at which solid substance melts and changes to liquid state at atmospheric pressure. For example, ice melts at 0 degrees Celsius. It converts to liquid. So melting point of ice is 0 degrees. At melting point, ice changes from solid to liquid. Remember, at 0 degrees of ice, we can see solid state as well as liquid state both. Both will exist. Different solids will have different melting points. Like melting point of ice is 0 degrees means melting point of wax is 63 degrees. Melting point of iron is very very high, 1535 degrees Celsius. Here we are going to learn a new topic, that is latent heat of fusion. Before going to learn that latent heat of fusion, we must know latent means. Generally latent means hidden, without visible to others, hidden. In previous experiment, whatever we explained, same thing with a different way. See, when ice is taken in a beaker, when I supplying heat to the ice, keep a thermometer inside the ice and check the temperature. At 0 degrees, ice starts melting and heat that ice. When supplying heat, the temperature of ice does not change. Still it shows 0 degrees. Until all the ice converts to liquid, till then the temperature shows 0 degrees. Even though I supply heat from down, still it shows the temperature is 0 degrees only. I am supplying heat, still temperature is not rising. How it is possible? What's happening there? That means when ice is taken in a beaker, when I am supplying heat, ice means solid state. The particles in a solid state has so strong force of attractions. If we supply heat to that, this heat is used by the particles to overcome these attractions, to increase the kinetic energy. This heat is used by the particles of ice. That is why it is not shown there in a thermometer. The thermometer will show the temperature, which is a measurement of heat, when it is reaching that, when the substance is liberating that. But the particles in the ice is absorbing that, overcoming attractions. So it is hidden inside the particles. That is why it is called latent, which means hidden. So let's say latent heat of fusion means, I will repeat once again, latent means, try to understand a number of times, repeatedly listen to this, you will understand very easily. Latent means hidden. I take an ice in a beaker, I am applying the heat. I kept the thermometer also inside that beaker. When ice is melting, Melting point of ice is 0 degrees. The temperature in the thermometer will show 0 degrees. If apply the heat, generally temperature should increase, but temperature won't increase till all the ice melts into liquid state. Till then the temperature will show 0 degrees only. Even though I am supplying the heat, the temperature still it is showing 0 degrees, because the heat supplied to the particles of ice, they absorb that heat, they will use that heat to overcome the attractions. It won't be, it is hidden in the particles. That is why we use the word latent, which means latent means hidden. Now let's go for latent heat of fusion means. Fusion means changing from solid to liquid. Okay. So latent heat of fusion means the amount of heat energy required to change 1 kg of solid to liquid at atmospheric pressure at its melting point. It is similar to melting point, slight variation. The amount of heat energy required to change 1 kg of solid to liquid at atmospheric pressure at its melting point is known as latent heat of fusion. So whatever the amount of energy is given to 1 kg of solid to convert from solid to liquid at its melting point at its atmospheric pressure is said to be latent heat of fusion. I think you will understand. If not repeated, listen to this. I am repeating once again. Latent heat of fusion is the amount of heat energy required by 1 kg of solid to convert to liquid at the atmospheric pressure at its melting point. Very simple. Go through this video, you will understand very clearly latent heat of fusion means. Next, in first case we discussed about solid to liquid. Now liquid to gas. In liquid to gas, I have taken a water in a beaker, I am heating this. Now water turns into water vapor, gaseous state. When we are heating the water, which turns into water vapor, that means liquid is changing into gases. Liquid is changing into gaseous state. How it is happening? And liquid is heated. In liquid, the particles of liquid has weak force of attractions. When I am supplying heat, this heat is absorbed by particles and they move with more kinetic energy, and the particles have sufficient kinetic energy to overcome that weak force of attractions and converts to gas. Very simple. I am repeating once again. When water is taken in a beaker, where you supply the heat, the water after some time changes to water vapor. How it is converting? Water has particles which are held together with a weak force of attraction. When I am supplying heat, these water particles absorb that heat, increase the kinetic energy, they will overcome these attractions and they will convert to gaseous state. They will come out with freely. Here we use the word boiling. Boiling is a process in which liquid converts to gases on heating. That is said to be boiling. Vaporization, the process of boiling the changing the state of liquid to gas is called vaporization. Both are same. Boiling and evaporation is same. Boiling point, the temperature at which liquid substance converts to gases at atmospheric pressure. It is similar to melting point, slight variation only. Melting point means the temperature at which solid converts to liquid, whereas boiling point means the temperature at which liquid converts to gas at atmospheric pressure. It is called boiling point of that particular substance. Generally, boiling point of water is 100 degrees. And remember, the boiling point of water is 100 means at 100 degrees Celsius we can see water which is in liquid state as well as gas, water vapor also. Both can exist at 100 degrees. Let's go for a new term, that is latent heat of vaporization. Latent means hidden. When water is taken in a beaker, when we are supplying heat, the water converts to water vapor. Keep the thermometer inside that. Check the temperature of that water. When it is boiling, at the boiling point it will show 100 degrees. At 100 degrees, the water which is in liquid state converts to gaseous state, but temperature shows 100 degrees only. Even though I supply the heat from down, still the temperature shows 100 degrees only. I am supplying heat. Temperature is a measurement of heat. When I supply more heat, still the temperature is 100 degrees only at the boiling point. At the boiling point, what happens means these particles of that water absorbs that heat, overcome the attractions, increase the kinetic energy. They will use that heat energy to increase their kinetic energy. That is why it is not shown as a temperature there. That is why there is no increase in temperature. This is hidden. These are used by the particles. So it is called hidden. So it is called latent. Latent heat of vaporization. The amount of heat energy required to change 1 kg of liquid to gas at atmospheric pressure at its boiling point. It is similar to latent heat of fusion. In latent heat of fusion, it is the amount of heat energy required to change 1 kg of solid to liquid at its melting point at atmospheric pressure. Here a slight variation. Latent heat of vaporization means amount of heat energy required to change 1 kg of liquid to gaseous state at atmospheric pressure at its boiling point. It is known as latent heat of vaporization. So this is today's topic. So today what we discussed means we are discussing about how to change state of a matter. It is affected by 2 factors. One is by changing temperature, second one is changing of pressure. Today we discussed about by changing temperature we can change that state also. Changing temperature means by supplying heat. Temperature is nothing but degree of measurement of heat. So go through this video clearly, we understand that all things. Thank you. Have a nice day.